Good day. I am JM, an ID 120 student taking up civil engineering, and I'll be teaching ENGMEC3 quiz number 1. Okay, now let us deal with our last problem. And the last problem would make use of concepts related to thermal stress and elastic deformation. So, the rigid bar ABCD of negligible weight is initially horizontal. And the steel rods attached at A and C are initially stress-free. So, it's important to note that no stress is applied at the initial condition. A 20 kip load is then applied and the temperature of the steel rods is changed by delta T. Find delta T for which the stresses in the two steel rods will be equal. Use alpha equals 6.5 times 10 to the negative 6 per degree Fahrenheit, and E is equal to 29 times 10 to the 6th power of pounds per square inch for steel. So in this problem, we have two bars that are two steel rods attached to the rigid bar, and similar to the previous problem, we know that it would apply an opposite force to where it is attached. We also know that we have a support at B, and this would mean that some of the weight is carried by this support. Therefore, it's an upward force, which we can label as F sub B, while let's label the two forces from the steel rods as FA and FC. And lastly, we also have our 20 kip load. So let's try first making equilibrium equations. So about B, let's start with at support B, convention of positive moment at the clockwise direction, the moment about point B must equal to 0. So we have here negative FA times 4 feet plus minus FC times 2 feet plus 20 kips times 2 plus 2 is 4 feet. So there. It equals to 0, and simplifying everything, we have 4FA plus 2FC is equal to 80. This is our equation 1. Next, we know that the stresses in the rods are equal. So this is the goal, to ensure that the stresses in the rods are equal. So let me highlight this part in the problem. So if the stresses in the rods are equal, this is our second correlational equation. So the force applied at A over its cross-sectional area, which is 0.75 square inches, must equal the force applied at C over its cross-sectional area of 0.5 square inches. Now, we can simplify it once again and get another correlation, which is FA is equal to 1.5 FC. Let's label it as equation 2. We have two equations with two unknowns. Therefore, we can solve for one of the forces. But first, we have to establish a compatibility equation. So now we can input 1.5 FC to FA here. So let's do it. So 4 times 1.5 is 6. So we'll get 6 FC or plus 2 FC is equal to 80. This simplifies to 8 FC is equal to 80, where FC will become 10. 10 kips. Therefore, our FA, where FA is equal to 1.5 FC, would just be 15 kips. So this satisfies both equations. And it's important to know this. So now let's establish the compatibility equation. So analyzing this figure, we know that a 20 kip force is applied. So it means that when you apply a 20 kip force here, the bar is supposedly going to move down. So if it moves down, and we know that there's a support here, the support here hinders movement up to this point. So let's draw a straight line. Then, since it hinders movement here, we know that there should be an upward movement or rotation at point B. So therefore, there would be an upward deformation or deflection at point A. So we can call this one as our deformation at A. And from here to the point where it is still parallel, we can call it the deformation at C. So knowing this, we can form our compatibility equation using right triangles, or the concept of similar triangles, wherein, let me just turn this into somewhat a triangle. Deformation at A over 4 is equal to deformation at C over 2. So let's copy this below as we develop our compatibility equation. Deformation at A over 4 is equal to deformation at C over 2. This would mean that deformation at A is equal to 2 times the deformation at C. It means that it doubles. Now let's apply combined stresses due to axial force as well as thermal force or thermal stress. So deformation at A can be equal to FA-LA over A of A times E of A. But since there are similar materials, let's just call this E plus alpha times the change in temperature times the length of A. On the other hand, for C, it's also the same, but we change the properties that has to be changed for this bar. So we know that the change in temperature would be equal since you apply it to the whole body. So therefore, if it increases by 5 degrees in the environment, let's say 5 degrees Fahrenheit, everything would increase by 5 degrees Fahrenheit. So now, let's try to get the values here and determine which ones will be unknown. So we can see in our givens that all are complete. We have here our lengths, our area, our E value, our alpha value, and we also have our forces. So let's compute or let's determine our unknowns or what it would look like. So here, the force is 15 kips, but we have a PSI unit for our E. So let's convert the kips into pounds. So it's just 15,000 or 15 times 1,000. So 15,000 times our length, which must be in inches. So 4 times 12 is 48 over the cross-sectional area being 0.75 times 29 times 10 to the 6 plus alpha is 6.5 times 10 to the negative 6 change in temperature times our length, which is again 48. The other hand here, it's just 10,000 times 36 over 0.5 times 29 times 10 to the 6 plus 6.5 times 10 to the negative 6 times change in temperature times 36. So we can equate this to using our compatibility equation rather. So let me just again write everything down below. So 10,048 times 0.75 times 29 times 10 to the 6 plus 6.5 times 10 to the negative 6 change in temperature times 48 is equal to 2. Remember, the 2 comes from the compatibility equation. It's 10,000 times 36 all over 0.5 square inches times 29 times 10 to the 6 psi plus 6.5 times 10 to the negative 6 times change in temperature times 36. So for this type of equations, we can solve it manually or we can shift solve. So using our shift solve in our calculators, the change in temperature must be equal to negative 106.10 degrees Fahrenheit. So what this entails is that the condition or the initial conditions of the bar was it being rigid. Then when you apply a force of 20 kips and the decrease in the temperature, the stresses would be equal. So that is all for the solved problems when it comes to ENGMEC3 Long Quiz 1. Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. Once again, this is JM from Syntax, paving your way to excellence. Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. Once again, this is JM from Syntax, paving your way to excellence.